Hello everyone. So today I'm here with class 12 chapter probability lecture number 2. In lecture number 1 we have discussed about the concept of conditional probability, and then we have done exercise 13.1 question number 1 to 5. Today we'll start from question number 6. Exercise 13.1 completely is based on one concept, which is conditional probability. So once you get it, the questions are really easy for us to solve. Okay, two things to note here is the first one, that from question number 6 to 10th we are going to find out probability of E by F in all questions from 6 to 10th. Okay, now in this, one more thing to note down is probability of E by F. As we all know, the formula would be probability of E intersection F divided by probability of F. Then we can write it as number of elements in E intersection F divided by number of elements in the sample space. Completely it would be divided by number of elements in F divided by number of elements in sample space. So these are going to get cancelled up. You're only going to be left with number of elements in E intersection F upon number of elements in F. So this is the formula basically that we can use. So we can just count the number of elements in E intersection F and number of elements in F, can divide them to find out the formula. So let us start with the first part of question number 6. Remember the formula, P of E by F will be calculated as number of elements in E intersection F given divided by number of elements in F. Okay, now see in this one how it is defined as event E and F. Before that, what is given to us? A coin is tossed 3 times. When we toss a coin 3 times, the sample space will have 8 outcomes, 2 to the power 3. The 8 outcomes will be head, 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 tail, head, tail, tail, head, tail, head, tail, head, head, tail, tail, head, tail, head, tail, and tail, tail, tails. So these are the 8 outcomes. As you can count, these are 80 numbers. This is a sample space. Let us write event E. In the event E, we have to write head on third toes, the outcomes in which head is there on the third toes. So first and second place, it can be either a head or a tail, right? We don't have to be concerned about it. We just have to see we should have head on third toes. So I see head, head, head. It has head on third toes. Then head, tail, head on third toes. Then tail, head on third toes. Tail, tail, head on third toe. So these are the 4 outcomes here. Now let us write F. In F, what do we have? They are mentioning F event as heads on first 2 toes. You should have head on the first 2 toes. In the third one, you can either have a head or a tail. That's not the case, right? So on the first 2 toes, you should have heads. So I see it is head, head, head. Then I see it is first 2 toes, a head should be there. H, H, and T. This one. So these are the 2 that will come up in F. Rest, there is no element, I say, on the outcome in which 2 heads on the first 2 places there, as you can see very carefully. Let us find out E intersection F. What is common in this? See, only one. H, H, H is common here. So number of elements is 1 in E intersection F. Now let us apply the formula for P of E by F that we just discussed is number of elements in E intersection F divided by number of elements in F. Number of elements in E intersection F is 1, elements in F is 2. So the probability for this will be 1 by 2. I hope this is quite clear to everyone. We have to write sample space. We have to write outcomes favorable to event E, outcomes favorable to event F. Then we have to count the number of element in E intersection F and place the values in formula. That's all you need to do for solving the questions for conditional probability. So let us move to the second part of it. In the second part, see, E is defined as at least two heads. What do you mean by at least two heads? Minimum you should have at least minimum number of heads that you should have is two, right? You can have three also, like minimum is two, you can have three more than that, but you can't have less than two heads. Similarly, F is defined as at most two heads, so maximum should be two. Then you can have one number of head, you can have zero number of head, but you can't have three heads. More than two you can't have. Maximum, the limit is two. So let us write the sample space again. We had the sample space as HHH, HHT, HTH, HTT, THH, TTH, THT, and TTT. So these are the 8 outcomes again that I have written. Let us write event E. In event E, they are defining event E as at least two heads. That means minimum number of heads that we should have is two. So we should count the elements, or we should pick up the elements or outcomes which have two or more than two heads. So HHH more than two heads, HHT two heads, HTH two heads, THH two heads. So these are the four outcomes. Let us write down F. In F they are asking you what? At most two heads. Maximum two heads you can have. You can't have more than two. You can have zero number of head, you can have one head, you can have two heads. So as it can be seen from the sample space, except HHH, all these seven elements will come up. Write them. HHT, HTH, HTT, THH, TTH, THT, because in these all we have zero, we have one head, we have maximum two heads. Now in E intersection F, how many elements are common in E intersection F? As we can see, HHTC, HHT is here as well, and this also. So HHT is common, HTH is also common. Writing that out. Then THH. Do we have THS? Yes, we have THH, as you can see it. THH. So the number of elements in E intersection F is 3. Let us apply the formula. P of E by F will be number of elements in E intersection F divided by number of elements in F. Number of elements in E intersection F you can see is 3, and F you have 7 number of elements. So the answer for this question, that we have to find out probability of E given the event F has already happened, is 3 by 7. I hope this is quite clear. So we have done second part of question 6, right? Third is similar to this only. It is also using at most and at least, just to see. So question number 6, the third part is for your homework. You are going to try this in your homework questions. Okay, let us now move to question number 7. Here is question number 7. Okay, very easy question. Let us just see what is it saying. So first of all, we form out the sample space. I'm reading the question out for you. It says two coins are tossed once. So when I toss two coins, see, the outcomes can be both the times I can get heads, both the times I can get tail, first time head, second time tail, or I can get tail on the first place, head in the second time. Yes, these are the four possibilities. So this is our sample space. In the first part, event E is defined as tail appears on one coin. Only one coin you should have a tail. So HT and TH, these are the favorable ones. Okay, in F, what are they saying? F is defined as how? One coin shows head. Only one coin will show head. So it is also HT and TH. Now as we can see clearly in their intersection, both are same actually. HT and TH will come. That means number of elements in E intersection F is 2. number of elements in E intersection F is 2. We have to find out probability of E by F. The formula is number of elements in E intersection F divided by number of elements in F. As you can see, number of elements in E intersection F is 2 and in F also it is 2. So the output is 1. So the probability of event E given that F has already happened is 1. I hope this is very easy question and well understood by you. So similarly, question number 7, second part can be done by you at home. It is also same. So we can go to question number 8 now. Here is question number 8. Okay, so here is question number 8. In question number 8, what are they saying? See, a die is thrown 3 times. When we throw a die 3 times, what are the possible outcomes when we throw a die? 6. Okay, how many times are we repeating it? 3 times. So the possible number of outcome in the sample space we will have all 216. Event E is defined as 4 appears on the third toss. So on the first and second it can be any, on the third toss it should be 4 only. So the possible outcomes are 1, 1, 4 like this. If I start with 1, then it will be 1, 2, 4, 1, 3, 4 up to I say 1, 6, 4. 4 should be there at the last, right? Similarly, we'll write with 2142. If I write 264. Then 3142, 314. Up to it will go 364. Similarly, 414. You see 4 is there every time on the third one. 464. Similarly, we will write with 5 and 6 as well. So these are the outcomes. So here 5, 6, 4. Here 6, 5, 4. 6, 6, 4 here. Okay, so these are, how many are these? As you can see in one line there are 6. Total we have 6. So number of elements is 36. Okay, so this is quite clear now. E we have written. Now let us write F. In F, what do we have to write? 6 and 5. In F, we have to write 6 and 5 are appearing in the first two tosses. So 6 and 5 first and 2 respectively. That means 6 is first, 5 is second. 6, 5, 1, 6, 5, 2, 6, 5, 3. Because on the third, it can be any number out of the 6 numbers. 6, 5, 4, 6, 5, 5, 6, 5, 6. This is the number of elements in event F. Okay, now we have to find out E by F. Okay, so for that, first of all, we should find out P of E intersection F, or let us find the number of elements in E intersection F. Here we have 651, 654, 655 like this, and in that we had these. In E we have these. So do you see 651 to 656? Do you see any element common here? As we can see here, see in the last line 614, we will get 654 before 664. No other element is common because here see on the first place 1, 1, 2, 1, 3, 1 is there. We want 6 and 5. So this is the only element which would be common in both of them. As you can see in F you have these. See here you have 654. So only one element is common, 6, 5 and 4. Now we have to find out probability of E intersection F. For that we need number of element in E intersection F divided by number of elements in F. E intersection F, only 1. Number of elements in F is 6. So the probability of E by F will be 1 by 6. I hope this is clear now. Now, as we have done up to question number 8, right? So question number 9, 10, 11 and up to so on, the complete exercise is to be done in the similar way. So for homework part, you will be doing from question number 9 to question number 17 of the exercise. Okay, I'm mentioning it. You people can note it down. For homework, you are going to do exercise 13.1, question 9 to 17. All these questions are of the same kind as we have discussed today. In the next lecture, I'll be giving you solutions to the questions which requires a little bit of trick. The basic questions can everybody solve now. Okay, thank you. Bye.